Alright, so this lesson is basically going to be looking into the angles of rotations, and I'm introducing a completely brand new measurement to you. Okay, and that is called Radian Measure. Okay, so kind of to understand exactly what a radian measure is you understand what a degree is. Okay, so if I say turn 30 degrees, you understand that that's like a rotation. Okay, well, a radian is the same exact kind of idea. It's a rotation. It is just a different unit to measure the rotation. Just like, for example, if I was going to measure the length of something, I could measure the length of this desk in inches, or I could measure it in centimeters. Okay, so it's just a different unit for measuring the same thing. Okay, so we're looking at rotation. So the first part of this is first understanding how to simply draw an angle of rotation. Okay, so oops, just draw that in highlighted form. Okay, so the way we look at this is for the angle of rotation, we basically draw this on a coordinate plane. Okay, so you see this right here. Okay, you might draw this in your notes. We have an x and a y axis, and we always start on the initial side. Okay, so the initial side is basically the x-axis working in a positive direction. So this is your initial side. Okay, and we're going to measure the angle upward in a counterclockwise direction. Okay, so this one looks to be over in the second quadrant. Okay, so this is theta, which is representing some degree, and it goes to this other ray, which we're going to call the terminal side. Okay, so there's a little bit of vocab for you. We've got an initial side, which always goes off of the x-axis in a positive direction, so we start from there, and then depending on our angle, we go to a ray, which represents our terminal side. Excuse me. Okay, so do notice that if we were to go straight up, this would be 90 degrees. Okay, so if I'm talking straight up and down here, let me kind of use a different color. Okay, so from the terminal side straight up on the y-axis, that would be 90-degree rotation. Okay, if I went straight out over here, okay, all on the x-axis, that would be 180-degree rotation. Okay, if I went to go straight down on the y-axis, so going all the way to here, okay, that straight down would be 270 degrees. And if I went all the way around and landed right back on the x-axis, that would be 360 degrees. Okay, so those are always done in a positive manner. So positive angles go counterclockwise. Okay, so you will also see negative angles. Okay, so here's another vocab word, coterminal angles. Okay, so a coterminal angle is an angle that shares the same terminal side. So an angle that shares the same terminal side. Okay, so this right here is an example. Okay, so if we have our initial side, okay, lying on the x-axis, if we go in a positive direction to 57 degrees, we land somewhere here in the third quadrant. Okay, so that's the positive. If we were going to go in a negative direction, you simply go clockwise. Okay, so this is going to land at the exact same place. So notice that that is a negative direction. So negative directions go clockwise. Okay, so they go downward, and we land in the exact same spot, which is called a coterminal angle. Okay, so coterminal angle. Okay, we could also have a coterminal angle where you do a complete full revolution. Okay, so this second example here is starting here on our terminal side. Okay, so We could say that if I just move straight from my terminal side up to this arrow, that kind of looks like it could be potentially 60 degrees. Well, you can see that this arrow goes all the way around the circle and comes back up. So it's doing more than 360. It's doing 360 plus the 60. Okay, so that's how we end up getting 420. Okay, so that is also a coterminal angle because it lands in the same place. My terminal arrow, that arrow, excuse me, I keep hitting all these buttons, still lands in the exact same spot. Let's see if we can get that off. Go away. There we go. Okay, so let's do a practice on that scenario. Okay, so for A, it says to draw an angle of rotation of 310 degrees. Okay, so in what quadrant will the terminal angle land? So here's our initial. Okay, so remember that straight up is 90 degrees. Straight to the left would be 180. Straight down is 270. And all the way around is 360. So if we're going 310, that's going to go past, it's going to be 40 degrees past 270 degrees. So, to the best of my ability, I'm going to draw a 40-degree angle off of there. Okay, and I'm going to show how I got there. So I rotated in a positive direction, and there's my terminal side. Okay, so which quadrant did I land? Remember, the quadrants go first, second, third, fourth. So we are landing in the fourth quadrant. Okay. So B says, on the same graph from the previous step, draw a positive coterminal angle. Okay, what is the angle measure? So if I have to go in a positive direction, I have to go upward. Okay, so basically what's going to happen here is I'm going to have to go a full revolution all the way around. Okay, so I know my terminal angle is going to land in the exact same spot. So there's my terminal angle. Okay, so there's my initial. So I'm going to have to go 360 degrees with an additional 310. So what angle did I land at? Okay, so our math is, what is 310 plus 360 degrees? Okay, so I landed at 670 degrees. Okay, so notice the way I drew that. Okay, so that's how we know exactly how we got there. So you need these little lines in here to show that you've gone potentially 360, or maybe you went in a negative direction, who knows. So make sure you draw that angle of rotation piece. Okay, now for C it says, on the same graph, from the previous two steps, we're going to draw a negative coterminal angle. Whoops. Okay, so a negative coterminal angle simply means we're going to go downwards. Okay, so here's my same terminal side. Okay, so this time, negative is going to go downward. Okay, so what is this angle going to be if I go downward? Okay, so to figure that out, I'm going to do 270, nope, sorry, not 270. What is my angle again? It was 310, there it is. Excuse me, 310, and we're going to subtract 360. So this is going to be a negative 50-degree angle. Okay, so going downwards. Alright, so I think drawing those is pretty simple. Okay, so the next part of this is now understanding what a radian measure is. Okay, so this is introducing this new measurement to you. Okay, so the way they do this is they basically are using the idea of the circle and its radius and an arc length. Okay, so to figure out what radian measure is, they show this picture with three separate arc lengths. Okay, so from A to B, we have a radius of 1. Okay, so they drew this right here. This will be my red one. Okay, at 225 degrees. From CD, the same angle, but this time has a wider radius, 2 times bigger. Okay, so going from there to there. And then the third one, E to F, now goes with a radius of 3, so 3 times bigger than the red one. Now don't assume that that is drawn to scale by any means, because it looks slightly off, but that's okay. Okay, so notice that the intercepted arcs have different lengths. Okay, so you can clearly see that the green arc is a bigger, longer distance than the red arc. Okay, even though they're all at the same angle. Okay, so the angle of rotation for all three of these is 225 degrees counterclockwise. There are how many degrees in a circle? 360. So to represent that as a ratio, we're basically going to take 200 and so this ratio is going to come from 225 over 360. So what would that reduce to? Okay, so if you want, you can grab your calculator and reduce it. So 225 divided by 360, and I'm going to hit math fraction because I want it as a fraction, a ratio, and that would be 5/8 of the circle. Okay, so 5/8. Okay, as opposed to going all the way around. So the arc length of the intercepted arc is a total of 5/8 of the total circumference of the circle. Okay, so here's a little exploration. So if we figure out how to find circumference, okay, I hope you remember that circumference of any circle is 2 pi r. So for our first circle with a radius of 1, we'd have 2 pi times 1, which you would agree would be 2 pi. Okay, for the second one, we'd have 2 pi times 2, which I hope you agree would be 4 pi. So we're keeping this in terms of pi. And the third one would be 2 pi times 3. And 2 times 3, that would give us 6 pi. So these are the circumferences of each of those circles. So now to figure out the length, the arc length, hopefully you can remember that all you're going to do is you're going to take the circumference and you're going to multiply by the ratio that we found before. Okay, so it's 5/8 of that circumference. So if you take 2 pi and multiply by 5/8, okay, so working with fractions, remember that 2 pi is the same as 2 pi over 1. So I can say, oh, let 2 and 8 can be reduced. 2 goes into 8 4 times. So now if I multiply the tops, I have 5 pi, and on the bottom I'd have 4. Okay, so that arc length would be 5 pi over 4. Now doing the same thing with the second circle. So I'm going to take 4 pi, so that's circumference, and multiply by 5/8 to find its arc length. So I'm going to again think of 4 pi as 4 pi over 1. 4 and 8 can be reduced. 4 goes into 8 twice. So this becomes 5 pi over 2. Let me draw that a little higher. There we go. And on my third one, I'm going to take my 6 pi and multiply that by 5/8. So 6 pi is 6 pi over 1. 6 and 8 can be reduced by 2. So 6 becomes 3. 8 becomes a 4. Multiply straight across. I have 3 pi times 5. So 15 pi. 4 times 1 is 4. Okay. So now the last thing they do is they're going to take the ratio of the arc length to the radius. So the S over the R right here. Let me put that in a highlighted form. So this is what becomes kind of interesting. Okay, so if I take my s of my red one, my first one, and divide by the radius, which was 1, we're going to have 5 pi over 4 divided by 1, and that just becomes 5 pi over 4. Okay, for the second one, I'm going to take my s of 5 pi over 2 and divide by 2. So remember that 2 is the same as 2 over 1. So if I divide by a fraction, that's the same as multiplying by its reciprocal. So 5 pi over 2 times 1/2. If I multiply those straight across, I have 5 pi on the top, and 2 times 2 on the bottom becomes 4. So the last one, if I take my s of 15 pi over 4 and divide that by 3, or 3 over 1, that would be the same as 15 pi over 4 times 1 over 3. And I can say 15 and 3 can be reduced. 3 goes into 15 5 times. And 5 pi times 1 is 5 pi over 4. And I hope you notice something. All of these ratios are the same. And maybe what you've figured out at this point is these are the radian measures. Okay, so what this means here is that the 225 degree, was it 225? Yes. The 225 degree angle that we measured from here to here. So this is a 225 degree angle. Well, that is equivalent to 5 pi over 4 in radians. Okay, that is just a measure of rotation. So, just to kind of summarize what we just did. Okay, so this is an interesting theory here. So, we take our circumference. Okay, so our circumference. And then what did we do? We multiplied by the ratio. So the ratio was the angle divided by 360. And then we took, so this is your S. And then we took that and then we divided by the R. S over R. So the radian measure, let's do radian. So circumference is 2 pi times r times the degree angle divided by 360, all being divided by the radius. So if we reduce this, the radiuses cancel, which means it doesn't matter how big the radius is ever. Okay, so we end up with 2 pi times the angle over 360, and if you wanted to reduce that, 2 and 360 can reduce to 180. So if you take the angle and multiply by pi over 180, you will then know what your radian is. Okay, so that is just the algebraic steps as to how to convert. So what I just found for you is the ratios that you're going to want to write down. Okay, so this is the part you want to write down. So we are going to be needing to convert from degrees to radians and radians to degrees. So all you're going to do to convert from degrees to radians is multiply by pi over 180. You might not write the radian piece right here, pi. I probably wouldn't. I would just say degrees times pi over 180. That's the way I'd write it. Equals radians. Okay. And if we're going to go from radians to degrees, all you're going to do to undo that is you just simply divide by pi over 180. And if you divide by a fraction, you multiply by the reciprocal. So you simply multiply by 180 over pi. So I would write, to get your degrees, you take the angle and you multiply by 180 over pi. So, to do some practice, let's see if I can, I'm going to pause this for a second and get some. Okay, so let's do some practicing here. Okay, so how do you go from degrees to radians? Okay, so here's example 1. So if we want to convert to radians, we are going to take the degree and we're going to multiply by pi over 180. Okay, so for the first example, we're going to take 20 degrees and multiply by pi over 180. So the way you want to think of this is we're going to squeeze it together into one fraction. So 20 pi over 180. So now we want to kind of ignore the pi and pretend that it was 20 over 180 and just reduce that as a fraction. Okay, so when I look at this I think, oh, the zeros cancel and then 2 goes into 18 9 times, so this is going to be pi over 9. Okay, so you're just working with fractions here. Okay, let's do 315. So let's do number 2. Okay, so we got 315 times pi over 180. So that's the same as 315 pi over 180. Now, this is a little bit more complicated as far as reducing the fraction. So you can use your calculator if you need to. Okay, so just working with the fraction, we want the pi to stay. I just have to reduce 315 over 180. So if I just reduce that as a fraction, I can type it in the calculator, 315 over 180, reduce it to a fraction, and so that would be 7/4. So my radian is going to be 7 pi over 4. Don't get rid of that. That pi still stays. Okay. So for 600, let's draw a line there. Kind of making that bigger. There we go. Okay, so for 600, we're going to take 600. Multiply by pi over 180. So that would be 600 pi over 180. So for this I see zeros that cancel. And 60 and 18, let's see, I'm thinking 6. Might be bigger than that. So 10, if I think 6 thirds, nope, that works. So 10 pi over 3. Okay, so you can do the same thing with negative measures. Now there's nothing different. You keep that degree negative, so I'm going to multiply negative 60 times pi over 180. So that's going to be negative 60 pi over 180. Zeros cancel. 6 and 18 can be reduced by 6, so it's going to be negative 1, which I'm just going to write as negative 1 pi over 3. So negative 60 degrees is the same as negative pi over 3. Okay, and the last one, if we take negative 540 and multiply by pi over 180, negative 540 pi, 180, divide by 9, negative 6, 9, 2, ooh, that goes further, ooh, interesting, negative 3 pi. Okay. Alright, so now if we want to go the other way and go from... Mommy, open it! Okay, so to go to radians, we're going to take the angle and we're going to undo what we did. So if we were multiplying by pi over 180, we're going to do 180 over pi here. So, I'm just going to take this over here. If I have pi over 8, I'm going to multiply that by 180 over pi. So hopefully what you notice on this one is that the pi's are always going to cancel out. So we're going to be left with 180 over 8. Let's see, we could reduce that by 4, I think. Hold on, let's try it. 180 divided by 8. Math fraction. So 4, yeah, so 45 halves. 45 halves, which if we're working with a degree measurement, we probably should write that as, let's see, what would that be, 22.5 degrees. So that would be a better understanding of what that angle is. So we'll go ahead and put that into a decimal form. If we're going to do 4 pi over 3, 4 pi over 3, multiply by 180 over pi. We're going to cancel that out. I see that 3 goes into 18 6 times, so that'll be a 60 on top. And 4 times 60 is 240 degrees. So that measure is the same there. So 9 pi over 2, 9 pi over 2 times 180 over pi. Pi's cancel. 2 goes into 180 90 times, and 90 times 9 is 8100. Wow, that is a big angle measure. Okay, so I'll do one more of these just with the negative so you see the negative, but it is no different. Negative 7 pi over 12, oh, that looks like a nice fraction, times 180 over pi. So again, the pi's cancel. I'm going to type this one in the calculator. Let's do, I'm just going to type in 7 times 180 because that's the top, and divide that by 12. Mac fraction. So this would be negative 105 degrees. Okay, so that is how to convert. So that then becomes kind of important when we then look at what is called the unit circle. Okay, so the unit circle is a big giant idea, basically taking this whole concept and putting a circle onto a coordinate grid. Okay, so this is going to become an incredibly important piece of trigonometry and doing a whole bunch of different things. So when you write down this unit circle here, put it, make sure it's eligible, make sure, or not eligible, make sure it's legible, make sure it's big. You're going to be using this a ton. Okay, so basically what we have here is a bunch of measurements. Okay, so when they use the unit circle, what they do is they use special triangles to kind of break it down. So our special triangles are 30, 60, 90 triangles. So you see 30 degrees and 60 degrees, and basically the increments of 30 degrees all the way around the circle. So you see 30, 60, 90, 120, 150, 180. Every one of those increments increases by 30 degrees. They also include the other special triangle of 45, 45, 90. So halfway in between this first quadrant is going to be a 45 degree angle. Okay, same thing right here. This is a 45 degree angle off your 90. Okay, so we are going to set this unit circle up. Let's use red. Okay, so all we're going to do is fill in the degree, and we're going to have the radian measure in there as well. So what is 30 degrees? So 30 degrees, if we multiply that by pi over 180, the zeros cancel, 3 goes into 18 6 times, so that would be equivalent to pi over 6. So this is pi over 6. And I'm going to do the 30s first because I want you to notice something about this. This is kind of an interesting thing. So if I was going to draw this terminal angle here, we could keep drawing each of these every 30 degrees. Okay? And what ends up happening is, do you see the top half of the circle that I just drew? Okay? The top half of my circle is, pretend it's a whole section. Okay? It's 1 pi. See how I have pi right here? 1 pi. Well, how many sections did I just cut my pi into? 1, 2, 3, 4, 5, 6. Well, this completely sections out my little pi here. So do you see that I have 1/6 right here? So the next section would be 2/6. So 2 pi over 6. 2/6 can reduce to 1/3. So this is the radian of pi over 3. Okay, the third one. Now I am at the third section. So 3 pi's out of 6 reduces to pi over 2. See how they give that to us? Okay, then I'm at 4 pi out of 6. There's 4 sections. So that reduces to 2 pi out of 3. So that is this angle right here. Okay, if I keep going, my next one would be 5 pi out of 6. 5 pi out of 6 cannot reduce, so that angle is 5 pi out of 6. Now I'm at 6 pi out of 6, which is equivalent to, pi. Keep going with this. Now we're at 7 pi. Whoops, excuse me. Good Lord. Okay, excuse me. So 7 pi out of 6. Can't reduce. That's the radian measure. Now I'm at 8 pi out of 6. That one can reduce to 4 pi out of 3. Okay, then I'm at 9 pi. 9 pi out of 6 reduces to 3 pi out of 2. 3 pi over 2. Okay, keep going. Now I'm at 10. So 10 pi of 6 reduces to 5 pi over 3. Keep going. 11. Now we're at 11 pi out of 6. Cannot reduce. And all the way around the circle, 12 pi out of 6 becomes 2 pi. So 0 degrees, which is also equivalent to 360 degrees, is 2 pi's. Okay. So let's see, make sure you have that drawn. Let's see if I can copy and paste this. Hold on, I'm going to pause this because I want to do 45 on a separate one. Okay, so if you need to stop and pause the video for a second to make sure that you have this all drawn, go ahead and do that. So I'm going to go back to this one, and now I'm going to do the same exact thing, but I'm going to do it in 45-degree increments instead. Okay, so I'm only doing the 45 degrees this time. Okay, I'll do this one in green. So here's my first 45-degree angle. Okay, if I go for another 45, I'm at 90. Another 45, what's 90 plus 45? 90 plus 45. 135. And then plus another 45. 180 degrees. Plus another 45 is 225. Plus another 45 is 306. Nope, sorry, not 360. 270 degrees. Plus another 45 is, what is that? 45, let's see, 315 degrees. And another 45, boom, 360. Okay, so using the same concept of cutting my pies. Okay, so on my top section, remember this is 1 pi, I start, how many sections do I have? So I have 1, 2, 3, 4 sections. So we're working with pi over 4. So this is my first section here. So 1 pi over 4 gives us pi over 4. So remember that's 45 degrees. I didn't write that previously. Okay, the second one, so this is 2 pi over 4. We've gotten this a couple different ways now. Is equal to pi over 2. So this is our 90-degree mark. Okay, third section, 3 pi over 4. Boom. 4 pi over 4, which is pi. Keep going. 5 pi over 4. 6 pi over 4. So you're straight down. So 6 pi over 4 gives you 3 pi over 2. 7 pi over 4. Can't reduce. Last one. 8 pi over 4 is, boom, 2 pi. Okay. So there is your unit circle. At some point I'll print off a nice unit circle for you so you have both of these on one sheet of paper. Okay. So as far as you need to know, I think that's all they're going to do with that unit circle for now. It's just working between radian and degrees measures, but you should definitely start memorizing this unit circle. So I don't think we need to do any more conversions between radians. I think you're okay with this real world example, just working with increments, and alright, so you should be good from there on.